Welcome, daring coders and Python enthusiasts. Today we embark on an exciting adventure into the world of file handling in Python. Imagine yourself as an intrepid explorer, delving into ancient libraries and uncovering secrets hidden in mystical texts. In the realm of programming, these texts are your files, and Python is your key to unlocking their mysteries. File handling, dear adventurers, is the art of reading from and writing to files. It's an essential skill for any Python journeyman, as it allows you to store and retrieve data, keep records of your quests, and even communicate with other explorers across the digital realm. In Python, opening a file is akin to unlocking a treasure chest. We use the open function, a magical key that allows us to peek inside the chest and discover its wonders. Here, we've used open to unlock treasuremap.txt in read mode, denoted by R. It's as if we're whispering to the chest, "Open up, but let's just look for now. But beware! An open treasure chest, if left unattended, can attract unwanted spirits. In coding terms, this means resource leaks and potential data loss. Hence, closing the file is as crucial as opening it. By invoking close, we seal the chest, ensuring our treasure or data is safe and sound. It's a practice as important as saying please and thank you in the world of Python. But our Python grimoire has an even more elegant spell, the with statement. This charm automatically closes the file for us, even if an error occurs during the file operations. In this incantation, treasuremap.txt is opened, and its contents are revealed. Once we step outside the with block, the chest locks itself, keeping everything in order. Reading a file in Python is like deciphering an ancient scroll. You unfurl the scroll and peruse its contents, unveiling the mysteries line by line. In this incantation, we use read to absorb the entire content of ancient_scroll. It's as if we've cast a spell to illuminate the entire scroll at once, revealing all its secrets. But what if our scroll is lengthy, filled with tales and wisdom? Python allows us to read it line by line, savoring each piece of knowledge as we go. Here, our for loop acts as a guiding light, revealing each line of endless_tale one by one. The strip method ensures we only see the text, free from any mystical formatting charms. Python, in its boundless wisdom, also offers other ways to read. The readline method whispers to us just one line, while redlines conjures up a list of all lines, like a summoning spell. With redline, we cautiously read the first incantation, but with redlines, we boldly summon all the spells at once, each as an element in a powerful list. Writing to a file in Python is akin to a bard composing a ballad. With a few strokes of the quill, or in our case, lines of code, we can record our tales for posterity. Behold, with the write method, we begin our chronicle in new_chronicles. The WW mode opens the scroll for writing, ready to accept our tales. But be wary, for this mode will replace old stories with new. What if we wish to add to existing legends rather than overwrite them? Fear not, for Python's append mode, denoted by A, is the tool we need. It allows us to add new lines to the end of a file, like a bard adding verses to an ongoing epic with open _saga, the A. Our new verse seamlessly joins the ongoing saga, enriching the tale without erasing what came before. Sometimes our stories are more than just a single line. Python's writelines method allows us to inscribe a list of lines in one fell swoop, like painting an elaborate mural with a broad brush. Here, writelines lines weaves a rich tapestry of words into epic_poem, each line a stroke of our grand narrative. Let us beware the dreaded file not found error. This error emerges like a sudden squall when Python cannot find the file you're trying to access. It's like searching for a hidden treasure island that isn't on the map. In our example, we try to open lost_treasure. But alas, if the file is not where we expect, Python raises the file not found error. With our try except block, we gracefully handle the situation, informing our crew of the missing map rather than letting the ship sink in confusion. Another common peril is the permission error. It strikes when we lack the necessary permissions to access a file, akin to a locked chest requiring a special key. It's as if the file is guarded by a fierce dragon, denying us entry. In this saga, we attempt to write to guarded_secrets. But without the dragon's permission, we face a permission error. Our try-accept spell allows us to respond wisely, acknowledging the guardian's refusal rather than crashing our quest. The sea of file handling is vast, and other errors like IO error and EO error lurk beneath its surface. These errors can occur during various file operations, throwing unexpected challenges at our Python vessel. By preparing for these errors, we can navigate our Python ship through choppy file waters with agility and foresight. Each try-accept charm we cast strengthens our vessel against these unpredictable tides. In Python, understanding file paths is like knowing the sea charts by heart. A file path tells Python where to find the treasure chest of data you're seeking, whether it's hidden on the same island or buried on a distant shore. There are two kinds of paths in the world of file navigation: absolute and relative. An absolute path is like a detailed map, showing the exact location of the treasure from a fixed point. A relative path, however, is more like a series of clues based on your current location. In our example, the absolute path precisely pinpoints the location of treasure map, text. The relative path, on the other hand, provides directions from the folder we're currently in, our ship's current location, so to speak. CSV, or comma-separated values, is like a scroll with information inscribed in a simple, table-like format. It's a favorite among merchants and scholars for its simplicity and ease of use. In this example, we use Python's CSV module to read potion_recipes. Each line in the file is a different potion recipe, neatly organized into ingredients and quantities. JSON, or JavaScript object notation, on the other hand, is like a magical tome, containing data in a structured yet highly flexible format. It's commonly used by wizards and alchemists for storing complex data like spells, enchantments, and configurations. Using Python's JSON module, we conjure the data from Spellbook into our Python script. The JSON data is transformed into a Python dictionary, allowing us to access our spells and incantations easily. And there you have it, brave explorers of Python. You've learned to unlock, read, write, and append to the treasure chests of data. With these skills, you're now equipped to navigate the vast and mysterious world of file handling. But remember, with great power comes great responsibility. Handle your files with care lest you unleash the dragons of data loss. Until next time, keep coding and keep exploring.